Hai, Assalamualaikum. My name is AINI ZAKIAH binti Muhammad Said, and today I will be presenting about an application of linear algebra called the Markov chain. So, Markov analysis is a method used to forecast the value of a variable whose predicted value is influenced only by its current state and not by any prior activity. In essence, it predicts a random variable based solely upon the current circumstances surrounding the variable. Markov chains are used in a variety of situations because they can be designed to model many real-world processes. This area range from animal population mapping to search engine algorithm, music composition, and speech recognition. To better understand this concept, let's take a look at this example. The Mathematics Club is organizing a food sale to generate funds for the club. They are offering bomboloni, nasi lemak, and cookies for sale. After analyzing their sales from the past couple weeks, the club members are looking for a way to estimate their future sales and predict how their sales will grow. They have noticed a trend in their sales data that allows them to predict the likelihood of selling each item based on what customers have bought on the previous day. So here, we can see if a customer bought a bomboloni for the first time, the probability of the customer to buy bomboloni again the next day is going to be 0.63. Meanwhile, the probability of the customer to buy a nasi lemak is going to be 0.22, and the probability for the customer to buy cookies on the next day is going to be 0.15, and so on. Notice how this whole diagram can be complicated and confusing to understand, right? So let's simplify this in the form of a matrix. Let the top be the preceding state, or in our case, the food that the customer bought on the previous day, and the right side going to be our new state, in our case, the food that our customer going to buy today. Like how we see here, if customer bought a bomboloni on the previous day, the probability of them to buy a bomboloni again on the next day is going to be 0.63. If they buy a nasi lemak on the previous day, the probability of them to buy a nasi lemak again on the next day is going to be 0.47. And if they buy cookies on the first day, the probability of them to buy a cookies again on the next day is going to be 0.38. And this is what we call a transition matrix that we are going to be denoted as capital P. Next, we are going to need a state vector X. What is a state vector? A state vector is basically the probability that a system is in a certain state at that time. Or to put it simply, the state vector is the probability of each of these items to be sold at that time. Like how we have here, x0 means this is the initial state vector, which means that the probability for a bomboloni to be sold is 0.5, and the probability of nasi lemak to be sold is going to be 0.3 and 0.2 for the cookies. Now, we are going to multiply the transition matrix with the initial vector state. This will result in a new state vector denoted as vector x1, which will be the new probability of those items being sold for the next day. Okay, so now what will happen? What will happen if we multiply the transition matrix over and over again every time we get a new state vector? Let's see. For example, if we take the initial vector state and multiply it with the transition matrix, we are going to get a new state vector denoted as x1, which is going to be the new state vector for day 1, which means that this state vector will be the probability of the items going to be sold for tomorrow, or day 2. And if we multiply the transition matrix with the vector state on the first day, we are going to get the vector state for day number 2. And the same goes if we multiply the transition matrix of day 2 with the transition matrix with the vector state number 2, we are going to get the new transition matrix for day 3, and so on. And look, and as we can see here, we found out that over time, the transition matrix is going to be a fixed number. At the end, we will see that the probability of bomboloni to get sold is 0.463, probability of nasi lemak going to be 0.314, and the probability of cookies to get sold is 0.223. So what can we make? So what can we conclude from this information? So for the conclusion, based on the calculations that we made above, we found that if the customer returns for the fourth time or more, the probability of those food items being sold converge to a fixed number. Therefore, it is safe to say that mathematics club sales will continue to grow steadily over time as customers will keep coming back to buy more of their goodies. That's it from me. Thank you.